Hey guys, this is Vance. What I thought I would do is talk a little bit about my house today. This is probably the biggest project I've ever done. I didn't do it on my own. I used the general contractor, but I designed it all myself. And what I thought I'd make this video about is the heating and cooling system. The heating and cooling system in my house, I custom designed. I did all the detail analysis on it, drew it up, everything, and I did the installation myself too with the help of a friend who had some experience. So behind me is Casa de Willis, and you can see about right here the air conditioner condensing units. And let me walk you through kind of how I designed it and show you some stuff about how the installation went on that. I designed my house and modeled it all based on a plan that my wife and I bought, and then I modeled it all in Revit. So this that you're looking at is Autodesk Revit. So this is the front of my house. And this is a complete 3D model of my house that I have here in Revit, which is awfully cool. So we're looking at a chunk of it here. So you can see the front door and everything. There's the garage, basement entries down here. This is the back side of the house, the back garage, the back patio. Right here is the actual air conditioning condensing units sitting right there. And so what I thought I would do is use this to show a little bit about the house. So let's take a look inside of it, if we can here. Okay, so the reason why I wanted to do this section here is so here's a cool section of my house now where you can see the inside. This is the living room, the dining room. This is almost cutting through the front door, right where you come in the front door. And this is the back patio. So down here are three equipment rooms, and the very bottom in the basement. That's how I designed it. The one on the right hand side here is the electrical room. That's where the load centers are and the security equipment and network stuff. This middle one is a safe room, so it's just a little concrete room we can go to as a storm shelter. And then this one on the left is the mechanical room, and I actually modeled in a lot of the HVAC equipment so you can see it there. So what we're looking at here in this room is this and this. Those two highlighted blue pieces are the air handlers inside the house. And this is the return air duct. So this is a 24-inch round piece of duct that comes from the trunk line and goes down into that air box. These are upflow, so air flows up through these things, gets combined, and goes out to the supply vent, which is this thing. So let me show you a different angle. Here we go. Okay, good. So what you can see from this view is this is looking in the top. So this is I cut off the floor and up, so we're just looking in on the basement floor plan. So here's that electrical room, safe room, and mechanical room, and you can see these two trunk lines. So this one here that I've just selected in blue is the return trunk, and what that's got is I've got a return air vent on either side of the house. One here on this end, one here on this end, and actually on each end I have two. Both of those return airs plenums come up into a corner where there's two walls, so there's actually four return air vents. Then this piece that's highlighted in blue now is the supply trunk. Now what's not shown on here is all of the takeoffs, because all the takeoffs are flexible, and I didn't CAD model all those, but I have them shown on a diagram that I'll show you now. Let's take a look at that. Okay, so here's the actual drawing page view that is the HVAC plan, and we'll zoom it up here a little bit where you can see what's going on. So you can see the air handlers are here. This is where the return air system is. You can see that trunk. And then everywhere there's one of these, you can see that there's all these floor registers shown, and each of these little dotted lines is just a detail line I drew in there with the diameter called out for the flex vent. So the trunk's here, and then you can see all the takeoffs. So there's quite a few. It's a pretty complicated system. I probably went overboard on it, but hey, it was my dream house, so I thought I'd do it up nice. So you can see all these going on here. I will just briefly tell you that I also did a pretty complicated heat and cooling load analysis to the house. Which is something I learned in engineering school, and it's often referred to as an ASHRAE Manual J, residential heating and cooling load analysis. So ASHRAE Manual J is the key word if you want to search that up. It's just the process of doing a determination of how much heat escapes through the walls and how much heat's gained, and it takes into account the surface area of the walls, floor and ceiling in all the rooms, and the materials that are used in the windows. It can be pretty complicated, but it ended up being a really massive spreadsheet that I'm not going to bore everybody with trying to show you all that. But I did that, and that's where I came up with all the CFM to all the different rooms. So that's how I sized all the trunks. That's how I sized all the flex lines and the registers and everything. So I did want to show you guys on the return air. So I was saying earlier that you can see this return air trunk goes the length of the house this way, and I'm going to zoom this in so you can see it. So what's going on here is this return air comes in, it comes up through the floor in this opening right here, and then on this wall there's a 20 by 25 register, and then on this wall I think there's a it's the same height. So I think it's a 14 maybe by 25, so it's a smaller vent going into the master bedroom, and then this larger vent goes into a larger hallway area, opens all up into here, and then on the other end over here, same sort of thing. On this end, we've got the vertical plenum, and then here into this big, large family room, there's a 20 by 25 wall vent, and then into here, into this rec room, there is a 14 by 25. So you can see this this rec room here is, you know, kind of large, so it has its own, in case this door's shut, and get air circulation in there. So I thought I'd show you guys that too. One of the things I did that was pretty cool is I've twinned these two air handlers together. So it's not like one heat system heats one part of the house and another system heats another part. They both do both. Or they both do the whole house is the best way to put it. The way that's done is they are staged. So both of them are heat pumps. Each of the two units that heat and cool my house is a 3-ton electric heat pump system. So each of those, so together they're 6 tons for my whole house, and but they're staged, and my thermostat stages them. So the way it works is there's 2 stages of cooling, one unit on or the other unit on, and then there's 4 stages of heating. You know, one heat pump, the second heat pump, then the first electric heat, and then the second electric heat, the auxiliary heat. So there's 4 stages of heating. So for that to work, it actually requires that the air handler fans are both running all the time, because you have to have the full airflow to circulate the whole house, which both of those air handler fans are in parallel the way this works. So that's how that staging is done, and it works out great actually. So a couple pictures I took back from when I did the construction. This is the metal frame. I made it out of 1-inch square steel tubing, welded it together. This is the frame after I painted it, and the frame that we're looking at here is the actual return air. You remember, you know, that box that we saw in CAD right underneath the air handler? So the 2 air handlers set on top of this thing. So this is it while I was wrapping it in sheet metal. This you can see on the end is the 24-inch opening for the return air for the whole house. And in these couple of views, these are views taken while the house was framed. So what we're looking at here, if you recall when we looked at the floor plan, this is a 20 by 25 opening, and it goes down, and on the other side you can see that 14 by 25 opening into the space in here, which is the master bedroom. And then this is just lined with I think like 1/4-inch plywood is what I ended up doing it, and then sealed it. And then this is the one on the other end. So this large 20 by 25 opening framed in, as well as the 14 by 25 into the playroom right in there. A couple of pictures I took during construction. This was a lot of work doing this, I'll be honest with you. I had a friend help me who had done this before. I'd never done it before. Fabricating all these duct work and sealing them. All the seams end up getting sealed with this duct seal stuff. This is a picture of my friend Chris helping me do it. This return air vent, there is this LVL beam right here, and we had to get it over to here, so we ended up doing a little piece that looked like this to jog it over to get to it in the basement. What else have I got here to show you? This is the inside of one of the T fittings that I made for that big, there's 2 big T's on that supply trunk. This is some of it installed. That's a T fitting up high before it was fully insulated, and before the house was done. This just shows some of the takeoff. So in CAD, I just modeled just the actual trunk. But then all of this flex line, I had to run all those to all those floor vents. This is the big 24-inch return air duct before it was insulated. Again, I slapped that duct sealant stuff on everything, which seals the duct up really good. Also, something my friend recommended is this is a vibration dampening piece right here. So this is like a flexible rubber piece. And there's one of those on the supply, one on the return, so that the air conditioning units themselves is like isolated from vibration from the actual ductwork. It's another picture there. This is some of the combining box where the air comes out of the 2 air handlers and goes in the combining box. Again, here is this rubber piece, this neoprene vibration isolator, all the duct seal in there. It's another picture of the same thing. Okay, so here we are. There's a water heater there in the corner, which you saw. We're not going to talk about that, though. We're going to talk about the heating and cooling system. So here are the 2 air handlers. These are 2 3-ton units that we talked about. I showed you earlier. There's that return air box on the bottom. Of course, it's all insulated. And then up here at the top, you can see the duct combining box up there. Let's go around to the back side, and you can see the return air. So if you recall on the video of the CAD, is a 24-inch diameter return air duct that goes up to the return air trunk. So that's the return air trunk there, and the supply trunk right next to it comes down here and goes into the return air box. So something really cool I'm going to show you is how to change the filters, because when I designed this box, I put the filters here. The filters aren't upstairs in the grates in the wall. They're here, so it makes them easy to change all in one place. I'll show you. So there's actually 4 wing nuts right in here that you take loose. So they're actually, I call them wing nuts, but they're actually wing bolts. So anyway, you take those 4 out, and then you can actually just lift this up, like you see here. And it gives you access to the inside. And again, I custom made this. There's a rubber seal all the way around, so when this little lid is closed, it's airtight. And then I designed it to use 2 very standard size air filters, 20 by 25 by 1. So all you do, lift those out like that. And we'll put our new ones in. Always checking the little arrow here to make sure the air flows in the right direction. And in this case, Air comes down the big pipe and goes in this way. So there's guides in there so that those can go in nicely and everything. And then close this little thing and put the bolts back in, and that's it. So it's pretty easy to change the air filters. Also, while I'm back here, I wanted to show you a couple other things I did that's custom. I added this enclosure onto the side of one unit, and I bought a larger transformer, that 24-volt transformer that runs both units instead of both units running their own transformer. Since it's one big system, I wanted to do it that way. The other thing is I wanted to talk a little bit about the thermostat. The thermostat upstairs has got this diagnostic system, and one of the things that it needs is these temperature sensors. So there's a temperature sensor mounted down in there, and there's the wires going up right there. And then up here on the outlet, there's a temperature sensor right there. They're all in behind the insulation. There's a temperature sensor there. And then those wires go over there to that little box on the wall, and that's the wiring center for that Honeywell thermostat. Let me also show you the condensate pump. So it's a condensate pump right here that both of the units drain into. That's for the condensate generated by the air conditioners. You'll also notice this one is a CPVC line that comes from the steam humidifier. I'm going to show you that in just a sec too. So this hose goes up and is connected into one of the septic drain lines for the house. Back here on the wall is the humidifier. So this is a steam humidification unit. Really cool. So in wintertime, this thing can keep the humidity in the house up. Connections for this thing, it has 240-volt electrical. That's what's coming in right there. You see in that black cord. Right down here, this is actually a drain. That's what you saw going over into the condensate pump. And then this is its city water supply line right here that I've got tapped into the city water line. And then this little thin wire here is the thermostat wire. This goes over there to that wiring center, and this is how the thermostat calls for humidity to be generated. So up here at the top, you'll see this is a rubber steam line with a insulator on the outside of it. This is a drain line for steam that condenses in the steam injector up there for it to drain back down. If you follow this up, it's probably hard to see on here, but this thing splits with a T into two. Because of how this ductwork is designed, I have two steam injectors instead of one, one on either side of the air handler there. With all the features of this thing, having 4 stages of heat, 2 stages of cooling, humidification and everything, it's got a lot of wires. So this is the wiring center for the Honeywell thermostat. Couple of breakers here on the wall. That's how the units are disconnected if you need to work on them. And then I want to talk about this box. This is a custom engineered box that I made. Really what's going on here is these are hour meters. And then there's some other controls I'm going to show you. So we've got an hour meter, or an odometer if you will, for unit 1 compressor, unit 1 aux heat, unit 2 compressor, unit 2 aux heat. And by unit 1 and unit 2, I mean the HVAC unit 1 and 2. So you can see now my unit 1 compressor's got about 16,000 hours. Unit 2 compressor's got about 20,000 hours. And the 2 electric heat modules have 400 and 500 hours on them. Also in this box is some LEDs that kind of just show you what's going on, what the system's doing. Can just give you a kind of a status report by looking at it. But the key thing that this box does, other than the hour meters, is it gives you the control of these 2 switches, which are big. So this switch is used to switch the whole system from being commanded by the thermostat to being commanded by the manual override system, which is just a bank of switches that's here in the box. This is good if you need to just disconnect the thermostat and run some tests. Then this switch actually swaps which unit is stage 1 and 2. So up here, that means HVAC unit number 1 is stage 1. Down here, it means HVAC unit number 1 is stage 2. That's good so you can swap it periodically based on the hour meter status so that one unit doesn't do all the work. Down here along the very bottom are just switches for controlling the various things that the thermostat automatically controls that you can control when it's in manual override mode. So I'll show you the inside of this thing. Again, I designed this box. It's custom, and I built it and everything. So let me show you what's on the inside here. So from right here, you can see the back of the lid with all the hour meters, switches, and LEDs. And then up here, you see there's a bunch of relays and a terminal block. So this terminal block is where all the wiring is done to all the equipment. All these relays are here to do the switching, the little bit of fancy switching that's done, swapping between units in stage 1 and stage 2. Okay, I wanted to take a minute and talk to you about the control panel box that you saw there in the basement. Well, this is a schematic for it. I'm going to put a link to this schematic in the video description. I don't want to go into the details of this because this took a little bit of effort to design, but just so you know how to interpret this thing. Along the top, these are the LEDs. These are the counter meters here on the right-hand side. Along the left-hand side are all the connections to all the different pieces of equipment. The 2 condensing units, the 2 air handlers, the thermostat, and the humidifier. Each relay, which is shown in schematic format here, has a little number down in the corner, 1, 2, 3, 4, etc. That corresponds to this little chart, and this will help you understand if somebody did decide that they wanted to kind of understand and do a version of that and duplicate it. This chart lists all the relays and a description of what each of the 2 contact states are and when it's energized based on how the circuit works. And then along the bottom here, these are the switches. So these are the switches where you can unit swap, you can do manual override, and you can switch in and out of the thermostat. A few notes down here in the corner about some assumptions that were made when I designed it. So I designed it back in 2010. I revised it a little bit just because I had to make a tweak to it and it was slightly out of date. But anyway, this is the schematic. It turned out more complicated than I wanted it to be honest with you. But it does its job and it works great. It's been running my system for I guess 7 years now, flawlessly. So at any rate, here's this, and I'll put this PDF link in the video description. So I thought I'd show you the thermostat I've got in my house too to run this system. There's not a lot of thermostats on the market that will do multi-stage units. So this particular one, and there's a few others you can get, will do 2 stages of cooling and 4 stages of heating. This one's a Honeywell. I actually started out with a White Rogers model, switched to this one. I'll show you why. This one's got a really neat feature that I like. This one also is Wi-Fi connected, so you can control it remotely with your phone and stuff like that. But let me show you real quick the diagnostic feature that's cool. The reason why this diagnostic feature is cool is because with a staged system, one of the 2 units, and I learned this because my first thermostat didn't have this diagnostic, one of the 2 units can go out and stop working, and because it's staged, it will just switch to the next stage, and you'll really have no way of knowing. So you'll find out that your first unit stopped working. You never found out about it until the second unit also stopped working, which kind of goes against what I wanted to do. I wanted a redundant system. So what this has got, this particular thermostat's got a feature where there's 2 temperature sensors mounted in the ductwork, so it measures the delta T across the actual heating and cooling unit. So let me show you how that works. So in this particular thermostat, what it's got that's pretty cool is the ability to diagnose problems. So if you go into menu, and installer options, you have to enter a secret code. You can get into this section here and you can set up the diagnostics. So what this will do is, first it will give you manual control over your 2 stages. And it's in equipment mode cool. So I can turn on and off stage 1 and stage 2 manually right here and set those limits. I can hit next step. You can set the limits here. I have not set up any limits for cooling. On heat, I could go in here and do my 2 stages of compressor, which is heat pump heating, and then my 2 stages of backup heat for a total of 4 stages. I can manually turn each one of them on and off, and then set the limits. And on this one, I have set the limits. So what I've set here is on stage 1, the temperature rise should be between, after running for 10 minutes, the temperature rise should be between 7 and 18 degrees. Stage 2, which is compressor 1 and 2 on, temperature rise should be between 10 and 23 degrees after 10 minutes of runtime. Stage 3, which is compressor 1 and 2 and backup heat 1 on, between 28 and 40 degrees. And then with all 4 stages on, which rarely occurs, it would have to be just well below freezing outside. But this is all 4 stages on, the temperature rise between 40 and 50 degrees. And then just note that it only measures that after 10 minutes of stabilization. So that's what I wanted to show you, which is pretty cool. So it will show up a warning if any of those temperature rises are off. So other than that, this thermostat also has an outdoor humidity and temperature sensor, which is a little module I have outside that's wireless that tells you the temperature and humidity outside. It also has the ability to control humidity. So I can set humidity on this. I think you do that. Here. So I can set what humidity I want. And I have a steam humidifier hooked up to my HVAC system, so this can generate humidity in the wintertime when the air gets real dry. Okay guys, thanks for watching my video. Hope it was informative to you. Showing off the cool HVAC system I designed here at Casa de Willis. It was fun doing it. I like this sort of thing, and I enjoyed it, and it worked out great. So hope you enjoyed it, and watch my other videos if you haven't, and I'll see you soon.